Welcome back. If you're just joining us now, my name is Professor Macadamia, and today I have joined with me a very special guest, the man who did the incredible. His name is Dr. Klundia. Everyone give a warm welcome to Dr. Klundia himself.
Well, I wouldn't go so far, but yes, it was quite impressive. Thanks for having me, by the way.
Oh, Dr. Klundia, you're being too modest. You truly have amazed all of us with your findings of phagocytosis in the wild. Some of our viewers have a few questions, though, about other functions of the cell membrane. Would you be willing to take some of your time and enlighten us with your knowledge?
Well, of course, I always have time to teach.
Great, just fantastic, absolutely splendid. Here, first caller, you're on the air.
Oh boy, I'm on TV. Oh, no, but that's not the point. I have a question. How does a cell take in molecules without using energy? Does it just eat it?
Ha, great question. And no, it doesn't eat it. How your cell does it, though, is through the use of protein channels. Take cellular respiration, for example. Your cell knows that it needs oxygen for cellular respiration, and there are more oxygen molecules on the outside of the cell than there are on the inside. So naturally, your cell allows the oxygen molecules that it needs to pass through the cell membrane without using energy by going through protein pumps. They're sort of like tunnels that lead into the cell. Then, the oxygen molecules that were outside of the cell are now inside of the cell so that your cell can use them.
Oh, that makes a lot of sense. You're really smart, Dr. Klundia. But what if I want to release the carbon dioxide molecules after cellular respiration? There's still a higher pressure outside of the cell than there is inside of the cell. So how do you do it?
Whoa, now that is where the action happens. Quite literally.
You see, the CO2 molecules from cellular respiration, which you're talking about, they're brought to the protein pumps. These protein pumps are on the cell membrane, and they use energy to take whatever molecules that the cell wants out, and they just push them out. They use that energy like a tube, so very similar to the protein channels, except the protein channels don't use energy. The protein pumps do, because the protein pumps are working on active transport, whereas the protein channels are working on passive transport.
So how is that different than exocytosis? I mean, the molecule is still leaving the cell.
Excellent thought, young man. The difference is that exocytosis is specifically for releasing substances by fusing a vesicle with the membrane. So that's a whole different process. Yes, it does the same thing, but it does it in a different way. See, the protein pumps, they go like a tube. They shoot it out. But exocytosis, it sort of spits it out. It makes a bubble and then pops that bubble on the outside so that the substance that was in it can then just go out. Did that answer your question?
Oh, gee golly, it did, Dr. Klundia. You're the smartest man I've ever met. Thank you so much.
Yes. Thank you so much for coming on today, Dr. Klundia. It was fantastic, absolutely splendid, spectacular, miraculous to meet you. You are quite an incredible person. But I'm sorry that's all the time we have. See you next time on Cells Tells.
This reporter signing off.